Hello, guys, and welcome back to another workshop in the 3D Printing Revolution workshop series. And today we're going to be talking about materials. So let's do a quick review on how 3D printing works. Basically, your first step in this process that you see on the right is that a tube-like material or a material shaped in a tube is fed through an extruder. Then the heated extruder melts the actual material, and then once the material is melted, it gets extruded out from the nozzle, and then it starts to cool down outside of the extruder, and it forms a certain shape. Now, as this cools down, the nozzle moves to form the actual shape, and voila, the shape is formed. The all rates at which this occurs can be configured in your 3D printing settings, but mainly it's the nozzle movement that it moves. For example, when you're 3D printing, the nozzle head moves from place to place for printing your actual object from bottom to top. Because as we learned before, 3D printing is just additive manufacturing from the bottom layer to the top layer. So what kind of materials um, can the 3D printer print? You got PLA, simple plastic, you got polycarbonate, and you got wood. So what can you not 3D print? So you cannot 3D print materials that cannot be melted into a semi-liquid state. You cannot print materials that burn instead of turning into a semi-liquid state. So this does not, the first one is for high tolerance, like it does not meet the high tolerance level, and the materials that burn do not meet the low tolerance level. And so the materials that you can 3D print must be between these two high and low tolerance these high and low tolerances. So let's go through some examples. Cloth. Okay, does this not meet the high or the low tolerance?
I would assume
The
it doesn't
low.
meet the high.
Doesn't meet the
If
high. Okay, show me.
I actually do see what Solomon is saying. My guess would have been that it would burn instead of turning into a semi-liquid state, but
Exactly.
Solomon's definitely does make sense though.
You're correct, Shigmi. It does not meet the low tolerance level because it burns before actually turning into a liquid state, semi-liquid state.
Oh wait, so low tolerance is if it burns?
Yes.
Okay.
Low tolerance is that it should not burn, but it does not meet that tolerance level.
Yeah. Okay,
So
I think I had them mixed up then.
yeah, it's a bit confusing. So paper, high or low?
The same, I guess.
Which is?
The low materials would burn.
Okay, low. Okay, rock.
I would say high for that one.
Okay, that's good. And then wood.
Didn't you say this could be printed?
Yes, yeah. I get into that. But just imagine a piece of wood, and when you put something really hot to it, what happens in the wild?
It would burn.
Yeah, exactly. So is it high or low?
Low.
What does it? It does not meet. Yeah, low. Okay, wood. Didn't I just say wood was a printable material? Well, this is different between real wood and wood filled material. So real wood is the wood that would actually burn, but you can actually mix two materials together. You can have PLA with wood grains, and because wood would get would burn up, that's why you would have a stronger PLA base. So often this would be the combination with 30% wood and 70% PLA in your material. It has just enough wood that it will not burn, that it will meet the low tolerance level. Plus, it will look like wood, like what you saw in the beginning slides. And this is similar, the process in which a hybrid material is made. So I'm going to talk about 3D printing houses. On the left, you see a 3D printer, big 3D industrial 3D printer, printing an actual house. Concrete is one of the materials that you can print with. So there have been news articles coming out saying that people are now 3D printing houses, actual big houses. But they can 3D print anything. On the right side, it's also a 3D printable house. But what's special about this is that the material that they used was biodegradable or is biodegradable. So it's kind of like sustainable living, like a tea hut in Native African times. They had lots of tea huts that I learned in class, and so that's biodegradable or made out of like just simple wood. And this house right here is also made of biodegradable material. So maybe your grandchildren's houses would be made of biodegradable material. You never know. Okay, I'm going to discuss the top 5 materials used for industrial 3D printing. Even we use some of these materials in our workshop series as well. So the first one is nylon. Some pros. Nylon, it's known for its durability. It has excellent strength to flexibility ratio, has very little warpage. What that means is that when you're printing an object, if the surrounding is too cold, then what it does is it starts to warp like that because there's not enough heat for it to stay down. This is a common 3D printing problem. Nylon can also be dyed or colored. Some cons: it should be kept dry at all times, and it has a shelf life of only 12 months. And this material can shrink during cooling, and thus the prints would be less precise. And also the printer suitability also varies because sometimes, like for example, our 3D printing team is getting upgrades to upgrade our 3D printers to be able to actually print nylon because we got upgrade our nozzle head to be able to support higher temperatures. ABS is another one. Pros is that it's the most accessible and cheap materials for 3D printing. It's highly available in lots of colors and has a longer lifespan compared to nylon. It's also mechanically strong. It's often used for high quality prototype production instead of just simple hobbyist work. Some cons is that it requires a heated bed when printing, and ABS materials have a very high melting point. And so when it gets on the board, on the bed, since the outside air is not as hot as the actual nozzle, there's lots of warping involved with printing ABS. And the filament is very non-biodegradable toxic material, and it releases lots of toxic fumes which you have to protect yourself at. Number 3 is resin. Resin is something like that, or there's different ways how people say it, but I say resin. Resin can be used in many applications, has low shrinkage, so it doesn't shrink as well as like any other materials when they cool down. They have a high chemical resistance, and they're rigid but also delicate. Some cons is it's very expensive. The filament also expires very soon or in a certain time limit, and it needs to be stored securely because it reacts high to any photosensitivity is pretty high. When it's exposed to heat, it can also cause premature polymerization. PLA, this is what most people use, hobbyists use as well. PLA is pretty easy to print, has a low warping. It can be printed on a cold surface. It can be you can print with sharp corners and features compared to ABS material. And you have different colors for PLA, of course. However, the PLA materials are not sturdy and they can deform when they're exposed to heat. Material is pretty less sturdy. And number 5, gold and silver. Some pros. Uh, it has high electrical conductance, as regular gold has, of course. It's heat proof. Printing with gold and silver, of course, is expensive, and it often takes a lot of effort and time to get it right because there are lots of minute things you have to worry about when actually printing the with gold and silver. And they also are difficult to work with lasers because of the high reflectivity and the high thermal conductivity that's present in in the gold and silver properties. And in order to print this, you often need a different kind of printer other than an FDM 3D printer. Okay, now we're going to look at a website which has a table of different materials. So what I'm going to do is I'm going to put that website in the link or in the chat, and they'll be able to see it all at once. I will also share my screen. If you see here, you can see all the different materials: ABS, flexible material, PLA, HIPS, all this. You can see that the stiffness of the flexible one is low because you kind of need it to be flexible, right? That's the whole point. So you got flexible one here. You got some of the prices put here. You got this entire table here. The least amount of printability, which is basically how easy it is to print based on oozing, warping, clogging, all the other common ones. You can see here, the hardest one is polypropylene. We're going to be printing nylon, and we can see that the temperature is pretty high, and that's why we need a extra upgrade rather than PLA, because PLA only requires 52 degrees Celsius, while a nylon is 80 to 95 degrees Celsius. But what's more cool is that nylon is also flexible. It's impact resistant, heat resistant, and fatigue resistant. And these are all the different features that similar that you can 3D print or the materials have. What the most interesting one, or this, I'll start with the second most interesting one, is UV resistant. So UV resistance is where is often used where you want to make like sunglasses, and that would use ASA. The first most interesting one to me is that you can make 3D prints that are dissolvable in actual water. How cool is that? You can make a print of, let's say, a dog. You put in water and it's gone. So we have hips is one of them that's dissolvable, and the other one is,
I could see the image shows it being dissolved in a liquid.
yeah, PVA. Yeah, PVA is there. Hips is there too. Oh, we also have metal filled and wood filled. Metal itself does not meet the high tolerance level, and so you have to put metal infused with PLA. And then you got wood filled. which does not meet wood does not meet the load tolerance, and that's why we talked about it being mixed with a PLA base. You also got durability. The most highest durability is nylon right here, so it's definitely useful in like drone frames, which we'll be using it in. You have the ultimate strength, maximum stress. PVA, surprisingly, has the highest, even though it's dissolvable. You got stiffness, durability, service temperature, price. You got a lot of stuff here, which is pretty interesting. So definitely check it out. Or check this table out. I'm sure these prices you can get them cheaper on Amazon or someplace. Yeah. Does anyone have any questions?
I don't have any right now.
I wanted to throw it back to the the 3D printing of the houses. So like,
Yeah.
what's the advantage of it? Is that like because it becomes prefabricated and all you have to do is just ship it and build it there, like on site, or?
Actually, I think most of the 3D printed houses are done on site. The reason why it's so special is that you often think that 3D printing is only used for like small materials, but with 3D printing houses, on the left, you're actually printing a house of your own design that's not in the market, and plus speed. I heard that you can, or when I was reading a news article, that they built like 10 houses in 1 month. So that was pretty fast. It was done with 3D printers. Also on the right side, you can 3D print houses that are biodegradable or printed with biodegradable material.
I think I've also seen a lot of them, or not a lot, but I've seen houses that were printed off site. And I know they were saying the reason for that is if you're in like a giant city or something where there's like little area for construction, you could more easily print off site and then
Oh,
just move all the pieces and then put it together. And so
interesting.
I've seen that happening a lot more on the news.
I guess that's also possible. I know that they're also 3D printing large boats.
Oh, that's interesting.
We need to get in the yacht game. Let's go.
Yacht, Navy battleship. Definitely. So that ends my workshop for today. Thank you for coming. This is my work cited. Does anyone have any other questions or comments or concerns? No? Okay. Well, thank you everyone for joining us today. And I hope that we'll see you next week and this Thursday for our Cyber Workshop series. So have a nice day.